everyone, I am SYED JAMESHA, Assistant Professor, Electronics and Communication Engineering, Allamin Engineering College, Autonomous, E-Road. I am going to present a topic name is Hazards in DPSD, Digital Principles System Design subject. Now we will go into the topic. Hazards definitions. What is hazards? Hazards is a unwanted switching transitions. What is unwanted switching transitions? That may appear at the output of a circuit because the different paths exhibit a different propagation delays. If example you have to take a 0 is the input, it will be propagates continuously, then the time in between in 1 will be added. Then if you take 1 inputs, it will propagates continuously, then it will be take a error is 0. So the 0 to 1 and 1 to 0, the transitions differently appears. That is the error fault will be created in the switching transmission of states. The exact name it is called hazards. The definition: hazard is a condition where a single variable can change. It will produces a momentary output change when no output change should occur. The input variable should be changes and the output also change a moment. That will be a moment the changes happen. I already told 0 transition is goes to 1, 1 transition is goes to 0. But the output change should not occurs. Here the next, what is the types of hazards? Here the 3 types of hazards which we are used in DPSD, asynchronous sequence circuits. Static 0 hazard. Static 0, what does it mean by static 0? The output goes 1 when it should remains at 0. The static 1 hazard, the output may go to 0 when it should remains at 1. Dynamic hazards, it causes the output to change 3 or more times when it should change from 1 to 0 or 0 to 1. Now let's see the example. The static 1 hazard, the transition actually happen, 1 transition is going there, suddenly it will be changing 1 to 0. This is the 1 to 0, the transition is happen. This is the single transition. That means in this 1 it will be changed by 0. That is static 1 hazard. In this hazard it will be created in the 1 transition, so it will be called as static 1 hazard. The same thing, the static 0 hazard, here the transition which will appears on the 0 continuation propagation, it will be changed by 0 to 1. So the 0 line will be changed at some time to 1. Some bit rise 1 values. So that is the errors happen in static 0 hazards. The dynamic hazard, here 1 transition is going, then suddenly 1 is going to suddenly down to 0 and 0 is going to rise the same 1, the same 1 is down to 0. Here the first change is happen, the first 1 to 0, the second change is happen 0 to 1, the third change is happen 1 to 0. So in this dynamic hazard, already definitions told 3 or more times changes will happen in this output. It will cause the name of hazard, that is a dynamic hazards. Okay. The next final one is the essential hazards. It is the most important hazards. It is relevant in asynchronous sequence circuits. Is the another type of hazards. It may occur ECE circuits, that is called essential hazard. What is essential hazard? The type of hazard caused by unequal delays along 2 or more paths that originates from the same input. We are not changing the input value, but happens the 2 or more paths originate unequal delays. That is the most important term used in this hazard. This type of hazard is called as essential hazard. Okay, we will see the example in next slide. In this diagram, there are two equations I have given here. Y is equal to x1 x2 plus x dash x2 dash into x3. B equal to B, y equal to x1 x2 plus x dash x2 dash x3 plus x1 x3. This is the equation which is given. We have to map the equation. In this first diagram, we have to frame the rows and columns. Here we have to frame two rows 0 and 1 because 2-bit instructions in inputs x2 x3, that are 2 bits instruction is 0 0 0 1 1 1 1 0. In this value, the shaded blue color values exactly in this equation. X1 x2 represent the value is 1. Where is x1 x2? Here x1 0 and 1, two values are there. Here 1 is the exact value x1. Here 0 is the x1 dash. So we can take this row. So we can take this row. Here x2 is there. So x2, where are the x2 already available in first term? Here third one bit is 1 1. The fourth one bit is 1 0. So here we have to mark the value 1. The second equation remaining x2 dash x3. What is x2 dash? X2 dash means x2 first value is 0. The second value is already x3 given 1. So here we are marking the value. So we have to we have to mark the value 1. So in this equation we have to mark two values. The same concepts is doing the next diagram. So here the groups will be separated. Here three groups in this diagram. Three groups are there. Group 1, group 2, group 3. The first diagram there are two groups. This is the real value. In this real value, the shaded means it will be the hazards happen here. The hazards here, the 0 to 1 transition hazards, that means static 0 hazard. 1 to 0 transition, that will be a static 1 hazard. Then 2 or more delays happen, that will be a dynamic hazards. So the three hazards statistic principles in this diagram we are used. So this is the best example. Future discuss a new topic. See you all again. Thank you very much. Thank you all.